everyone. Here is another video on continuous charge distribution. So in the previous videos we have studied how to calculate electric field for a discrete system of charges, where we have seen if charges are in discrete form, that is you can separate, you can distinctly point the charges. Suppose this one is Q1, this one is Q0, this one is Q2. These are discrete set of charges, that is you can easily distinguish one charge from the other. So in this case we have seen that electric field E is given by the principle of superposition is used to calculate the electric field, and we have seen electric field is given by 1 by 4 pi epsilon naught summation of I equals to 1 to n, where n is the total number of charges present, and Qi by R IP square into R IP unit vector. Okay, so this is the unit vector points in the direction of unit in the electric field, and R IP is all the charges and its distance from the test charge. Okay, so this is the using the principle of superposition. And in terms of position vectors, we have seen it can be written as 1 by 4 pi epsilon naught I equals to 1 to n Qi by R minus Ri vector. So we all have studied this in the previous video. Those who have not seen the previous video, please do see it so that you are able to understand how this E comes. Okay, and another thing, in the last video in one of the places I missed putting the square, so please be careful. Don't forget to put this as square. Okay, so this was all about the charge system due to discrete set of charges. That means when you are able to distinguish one charge from the other. Today we are going to learn about the continuous charge distribution. So what is continuous charge distribution? Suppose there is a charge system where the charges are closely packed, that is there are infinite number of charges and there is very little space between the charges. Okay, so this is known as continuous system of charges, continuous charge distribution. So in this type of charge distribution, if you are asked if you are asked to calculate the force due to this continuous system of charges, what we can do? We can calculate. We can draw in this manner. We can draw a charge system, and we can consider a small volume where we take that this portion has a charge, suppose dq. Okay, and we want to, and here is a test charge q0, and this distance is r is the distance between dq and q0. And if you want to calculate the force, how you will calculate? So in a continuous charge distribution, since dq is the small amount of charge, here also we are writing df, that is this force is small force. So 1 by 4 pi epsilon naught. So q0 dq by r square, where r is the unit vector. R is the unit vector pointing in the direction from, r is the unit vector which points in the direction dq towards q0. Okay, points in the direction of, I think it's not visible, points in the direction from dq towards q naught. Okay, so r is this unit vector. Now what is total force? Total force due to the continuous charge distribution. Continuous charge distribution will be equals to F equals to dF. Okay, and that will be equal. So why we are using integration? So integration is used whenever we use a continuous charge distribution, and summation is used whenever we are using discrete system of charge. That is, you can distinguish each and every charge from one another. Okay, but when there is a continuous system of charge, it means you cannot distinguish one charge from the another. We use the integration of charge, integration sign. So in integration, what we will do? 1 by 4 pi epsilon naught q naught dq by r square, r unit vector, so now what will happen? 1 by 4 pi epsilon naught is the constant part. You all have studied in integration that all the constant part comes out, and what remains? This is the portion. We can write this portion in this form. Okay, so this is the form that we can write. So this is the form of the force for a continuous charge distribution. Now, there are 3 different types of charge distributions. Okay, so what are the 3 types of distribution, continuous charge distribution? So the 3 types of charge distributions are, continuous charge distributions are volume charge distribution, surface charge distribution, and line charge distribution. So let us see how this can be represented. So let us first of all start with volume charge distribution. So in volume charge distribution, we take a volume, it is represented by V. It is a 3-dimensional surface, and let us consider a small element of this volume and name it as dV, and it has dq amount of charge. Okay, and the distance of this charge from a test charge q naught is r. So here we shall define a quantity known as volume charge density, and it is given by rho. Rho is equal to dq by dv, that is charge per unit volume. Okay, and its unit is, an SI unit of rho is coulomb per meter cube. So this we can understand why charge by volume, it is given in this manner. So if you are asked to find out the force due to this volume charge density, how we can find it out? So we can write down the formula of force as, we can write this as V, and F of V is Q naught by 4 pi epsilon naught. We know it is dq by r square, r unit vector. So here we can write Q naught by 4 pi epsilon naught. In place of dq, we can write rho dv by r square, r unit vector. Why? Because rho equals to dq by dv. So dq equals to rho dv. Okay. So next, if you want to find out, here you should add a vector. So here if you want to find out the electric field, how you will write? So electric field is F of V vector by the test charge Q naught. So that means if you write this, if you divide this by q naught, what you will get? 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught integration of dv r square. So this is the formula of electric field due to volume charge distribution. In surface charge distribution, what we do, we take a two-dimensional surface. Suppose this is a two-dimensional surface, and we take a small element of this surface, and let this be of area ds. Total area is s, and suppose it has a charge dq, and it is at a distance r from the test charge q naught. We want to calculate the force and electric field due to this charge at this portion. So here we have another parameter known as surface charge density, and it is given by sigma. It is given by sigma equals to dq by ds, where that is, it is charge per unit area. And what will be its unit? SI unit will be, its SI unit is, so coulomb per meter square. Since this is area, we will have here meter square. So here how to find out the force due to this. So force we can easily find out, same as the previous method. So here we will write force as F of S. So q naught by 4 pi epsilon naught integration dq by r square r unit vector, where we will write q naught by 4 pi epsilon naught in place of, so if this is like this, so what we will get, dq equals to sigma into ds. So dq is sigma into ds by r square r unit vector. And electric field, how we can get? Electric field is f of s vector by q naught. So q naught will get cancelled if you divide fs by q naught. So it will be ds by r square r unit vector. So this is how you can represent a surface charge distribution. Third number case is line charge density. So here what we do, we will calculate the charge distribution along a one-dimensional curve. So it looks like a line, and here charge is distributed, suppose like this, over a line. Okay, so in this case, what we can do, we can consider a small element like this. We can consider, like suppose this is of length dl, and suppose we take and it consists of charge dq, and suppose we want to calculate the force and electric field due to this dq amount on this test charge. Okay, and it is at a distance r from this dq element. Okay, so this is of dl is this much amount. So line charge density is given by lambda, which is equals to charge by dl. dl we can say, and what will be its SI unit? SI unit will be equal to coulomb per meter. So we can easily understand why it is coulomb per meter, because charge by length. So this is how we can represent line charge density. So if you want to find out the force, so force will be f of subscript L will be equals to, we know this formula, by r square I unit vector dq by 4 pi epsilon naught. dq will be lambda dl by r square r unit vector, and suppose if you want to find out the electric field, so how you will write? You will write it in terms of L by Q naught. So 1 by 4 pi epsilon naught lambda dr by r square. Since lambda equals to dq by dl and dq, therefore dq will be lambda dl. Okay. dq equals to lambda dl. So in this way we can write. So in the charge system, in the surface charge system also, you can add charge in this manner also. Or otherwise, if you don't want to show that it is charge, you can just say that it is a surface charge density if you do not want to show the plus signs. So you can just say that it is a surface charge density. Sorry, line charge density in this case. So you can say, and then also we can understand that it has a charge over this curve. Okay. So I hope you all have understood today's video, and do comment and also like if you have understood. Thank you.